Hello dear students, welcome back to Chemistry Online class. This is the fifth video on the chapter periodic table. Okay, in the last video, that is fourth video, I have taught you about the modern periodic tables. Modern periodic table, some terms in reference to modern periodic tables like groups, periods, and the names of some special groups like alkali metals, alkaline earth metals, boron family, carbon family, inert gases, halogens, all those things I explained. Next, I have explained you about this transition elements, inert transition elements, that's lanthanides and actinides, all those things I have explained you. Okay, so today I'll continue from that section only. Last part of fourth video, I was talking about the periodicity and periodic properties of an element. Okay, so you note one question. What do you mean by periodic properties of an element and periodicity? Okay, so answer will be periodic properties. Periodic properties of an element are the properties which repeats after some interval. Okay, or the properties of elements in which there is a regular variation, okay, increasing or decreasing type of variation, and such type of properties are known as periodic properties. And the phenomena in repetition of such properties is known as periodicity of the elements. Okay, next, cause of periodicity. Cause of periodicity, periodicity, periodicity. There is repetition in the properties of an element because of similar type of electronic configuration. Okay, so cause of periodicity is recurrence in the electronic configuration, recurrence in similar type of electronic configuration of the elements. Okay, so for example, electronic configuration of say lithium is 2,1, beryllium is 2,2, next boron is 2,3, carbon 2,4, nitrogen 2,5, oxygen 2,6, oxygen. After that we have fluorine 2,7, after that neon 2,8. This is the electronic configurations. Okay, next we have sodium is 2,8,1, next sodium magnesium is 2,8,2, aluminium is 2,8,3. so there is recurrence in the electronic configuration, similar type of electronic configuration is there, 2,1, 2,2, 2,3. Again there is repetition, this 2 is there, 2 and 1 is there, this 2 and 1. So lithium resembles sodium. Okay, similarly you have 2,2 here, and here also you have 2,2. Forget about this middle part, 2,2. So there is the recurrence in the electronic configuration. Okay, similar type of electronic configuration is there, and that is the reason for periodicity. Okay, now let's move on to another topic, that is properties of transition elements. Okay, TIS, properties of transition, transition elements. So you can write a question, state some properties of transition elements. Transition elements I have already explained to you in the previous class. They are the elements of group 3 to 12, middle portion. Okay, in the periodic table they are called transition elements. Elements from group 3 to 12 are called as transition elements. So their properties are, first is they are all metals. Okay, they are all metals. whatever elements are there in that transition series, that middle portion, they are all metals. Okay, so first property is that. Number B, second is they have high melting and boiling point. Okay. Number C is they are generally good conductor of heat and electricity. Okay, they are generally good conductors of heat and electricity. Number D, you can write generally they show variable valencies. Like for example, iron Fe, it has two valencies, one is 2 and 3. Sometimes valency of iron is 2 and sometimes it is 3. Similarly, copper is 1 and 2. Similarly, there are also other metals with variable valencies. Okay, so generally they show variable valencies. And number E is very, very important. Most of the elements of this transition series, okay, they form colored ions. Their ions will have some colors. For example, color of Fe2 plus ion is green. This is ferrous ion. Okay, Fe2 plus ion, it has green color. Similarly, ferric ion Fe3 plus has yellowish brown color. Okay, next nickel 2 plus ion has green color. Manganese 2 plus ion, Mn 2 plus ion, has pink color. So most of the elements of this transition, elements, okay, they form colored ions. For example, you can give iron 2 plus has green, it is green in color. Iron 3 plus, it is yellowish brown in color. Nickel 2 plus, it is green in color. Manganese 2 plus, it is pink in color. Okay, so first is they are all metals. First property is they are all metals. Number B is what I said, they are good conductors of heat and electricity. Okay, number C, what I said, number C, they show variable valencies. Number D, they form colored ions. Okay, so you write at least 5 properties, 5 or 6 properties. Next is properties of inner transition elements. INNER, inner transition, TRANSITION, transition elements. Inner transition elements means I have already explained you in previous class. Lanthanides and actinides are known as inner transition elements. Okay, they are kept separately in the periodic table. So lanthanides and actinides, lanthanides means from atomic number 57 to 71, and actinides means from atomic number 89 to 103. So lanthanides and actinides are said as inner transition elements, and their properties are: number 1, again they are all metals. Okay. Number B, most of them form colored ions. Okay. Number C, this is very, very important, this actinides. Okay, actinides of these inner transition elements, they show a special property. That property is called radioactive properties. Okay, they are radioactive in nature. So you won't find this actinides in nature. Okay, they are generally prepared in laboratories, special laboratories. Now let's move on to another topic. For this also you form a question. Okay, write it. Mention some special properties of inner transition elements. And so write it. Some special properties of inner transition elements are: they are mostly metals. They are all metals. Okay. Number B, you can write what I said. Number B, I said they show variable valencies. Okay. Number C, they form, most of them will form colored ions. Okay. Number D, The actinides of inner transition elements show the properties of radioactivity. Radioactivity means special properties of elements, okay, to emit particles like alpha particles, beta particles, and gamma particles that you can you have to study in another class 10, okay. Now let's move on to the merits of modern periodic table. MPT means modern periodic table, okay. In short form I have written like this, MPT. You write it properly, okay. Modern periodic table. So you can note a question, state some merits of modern periodic table. So number one is modern periodic table is designed in increasing order of atomic numbers, okay, and this increasing order of atomic numbers is better than the previous classification, that is increasing order of atomic mass. This atomic number is better fundamental property in comparison to atomic mass. So first is that one. So modern periodic table is designed according to increasing order of atomic numbers, which is the better fundamental properties of an element, okay. Number two, modern periodic table is easy to understand and it is easy to memorize, okay. Number three, from the modern periodic table you can write the electronic configuration of elements, you can predict the properties of elements, their atomic size, okay, their valencies, their number of orbits, everything in a easiest manner. So that is the third merit of modern periodic table, okay. And you can refer your book for some more merits. Next is demerits or defects in modern periodic table. Some of the defects of modern periodic table. Number one is, you make a question, okay, state two defects in modern periodic table, okay, or state some demerits of modern periodic table. So answer will be, first of all, the position of hydrogen is controversial in modern periodic table, okay. Hydrogen, it is a non-metal. Hydrogen is kept in first position. Here you have helium, here you have helium, here you have lithium, after that beryllium, after that boron, carbon, whatever is there, you have sodium, magnesium, aluminum, and so on, okay. So hydrogen is kept in group 1 of modern periodic table, so that is controversial, okay. Hydrogen is a non-metal, so it should be kept in group 17, but it is kept in group 1 with the metals, okay. So that is the first demerit in modern periodic table. And the second demerit is position of lanthanides and actinides, that is inner transition elements. This modern periodic table fails to accommodate inner transition elements, that is lanthanides and actinides, in the mainstream. In last video I have said that lanthanides and actinides, okay, they are kept separately in the modern periodic table. So this modern periodic table fails to keep lanthanides and actinides in the mainstream, in the main body of modern periodic table, okay. So two defects are there. Number one, position of hydrogen is controversial. Hydrogen is non-metal, so it should be kept in group 17, but in modern periodic table it is kept in group 1 with strong metals, okay. So that is the first defect. And number two, modern periodic table fails to accommodate lanthanides and actinides in the mainstream. Lanthanides and actinides are kept separately in the modern periodic table, okay. So that is the second defect, okay. Next, let's move on to some properties, periodic properties. periodic properties of elements and variation in periodic table. Atomic size. Number 2, number 1 is atomic size, number 2 is number of cells or orbits. Okay, number 3 is number of valence electrons. Number 4 is valency. Number 5 is you can write metallic character. Number 6, non-metallic character. Number 7, there are some more properties. Okay, electron affinity. Electron affinity is there. Electronegativity is there. Okay, ionization potential is there. Oxidation nature, reducing nature, all those things are there. But that is not there in your syllabus. Class 9 standard, it is not there. Okay, so let's write up to this. Atomic size I wrote. Number of cells I wrote. Valence electrons, valency, metallic electron. Okay, these are some periodic properties. So you can note a question. Okay, actually this question will not come like this. So just note a question. Okay, state some periodic properties and mention how it varies in the modern periodic table. So just write down that question. So some periodic properties are atomic size. Number 1, atomic size. Number 2, number of cells or orbits. Number 3, number of valence electrons. Okay, number 4, valency. Number 5, metallic character. Number 6, non-metallic characters. And there are some more properties like ionization potential, electron affinity, electronegativity, okay, oxidizing nature, reducing nature. So many things are there. Let's do up to this one there. Atomic size. When you move from left to right along a period, so it decreases. D means decreases. Okay, from left to right. This arrow shows from left to right along. This is period. Okay, this is and this arrow shows groups. Vertical arrow shows groups and horizontal arrow shows periods. Okay, this arrow indicates this from left to right. Arrow shows from left towards right. Okay, and this arrow shows from top to bottom. So atomic size of an element decreases when you move from left to right across a period, across a particular period. Okay, so atomic size decreases, and when you move down, then it will increase. Atomic size increases. So top to bottom, okay, atomic size of an element increases. Number 2, number of cells. This side, left to right, across a period remains same. Remains the same. Number of cells or orbits from left to right, it will remain same. Left to right across a period remains same, and top to bottom it will increase. Top to bottom it increases. Okay. So number of valence electrons. Number of valence electrons along a period from left to right, it increases like this. 1, 2, 3, 4. Okay, from 4 again it will decrease. 3, to 1 and ultimately it becomes 0. So number of valence no, not like this. This is for valency. Valence electrons increases, okay? Increases across a period. That is, it will increase like this. First is 1, second is 2, 3, 4, 5, 6, 7, and ultimately it becomes 8. Okay? So it increases from 1 till 8 across a period. Number of valence electrons will increase when you move from left towards right across a period. Okay? And down a group, number of valence electrons remains same. This is remains the same. Down a group, it will remain the same. It remains constant. For group 1, it is 1. For group 2, it is 2. For group 3, it is 3. Okay, group 13, it is 3. Like that. Okay, next we have valency. This is for valency, okay. Number 4 is valency. From left towards right, valency will increase like this. 1, 2, 3, 4, and again it will decrease. 3, 2, 1, and ultimately becomes 0. For inert gases, valency is 0. For group 1 elements, valency is 1. For group 2, valency is 2. For group 3, group 13, 3 means group 13. Okay, valency is 3. 14, for 14, valency is 4. 15, valency is 3, like that. Ultimately it becomes 0. So across a period from left to right, valency of an element increases from 1, 2, 3, 4, okay, and then again it will decrease. That is, becomes 3 to 1 and ultimately 0. Okay. Next, down a group, it remains constant or same. Remains the same. Okay, so valency we have completed. Metallic character. Metallic character, when you move from left to right across a period, metallic character decreases. So left side you will have, on left side of modern periodic table you will have strong metal, and when you move towards right hand side, the metallic character slowly decreases, and ultimately on the right hand side corner the elements will be non-metals. Okay. Down a group it will increase. Down a group from top to bottom. Okay, this arrow shows from top to bottom. Next is a non-metallic character. It is opposite of a metallic character. So when you move from left to right, non-metallic character increases, and when you move from top to bottom, it will decrease. Okay, so this is how some periodic properties varies in modern periodic table. So you make a proper note of these things, okay? So you can write the answers like this. Number 1, some periodic properties of an element are, number 1, what I said, atomic size, ATOMIC, atomic size. So variation in atomic size. Variation in ATOMIC, atomic size. Number A, along ALONG, along a period, PERIOD, along a period from left towards right. Atomic size, ATOMIC, atomic size decreases. Okay. Number B, down a group from from TOP, top to the bottom. Atomic size